You've probably heard that it is impossible to accelerate matter faster than light. And if you have any experience in quantum mechanics, maybe you know that it is impossible to measure position and momentum of a particle at once. But what if you could violate quantum mechanics and actually do these things? The EPR paradox, or Einstein-Podolsky-Rosen paradox, makes this possible. In order to understand what the EPR paradox is, we need to start with states. The definition of a state is pretty vague, so only for this video, I'm going to say that a state is a vector and represents something in the system. One example of this is the spin of the particle, which is kind of like the angular momentum of the particle, and you can have spin along some axes and represent spin as two numbers, or maybe even three usually. Another key idea is superposition. I'm not going to go too deep into this, but the basics is that a particle can occupy two states at once, and you do not know which we have measured. The most important idea for the EPR paradox is entanglement. Essentially, this means that the state of two particles are now correlated. That means that the states of each particle are dependent on each other. And another part of the EPR paradox is how it violates Heisenberg's uncertainty principle. The uncertainty principle basically says that there's a limit to how accurate a measurement can be with certain pairs of physical properties. Now we can understand the EPR paradox. The original EPR paradox was a thought experiment made by Einstein. Imagine we have two particles, A and B, that just interacted and are now entangled and are flying two opposite directions and do not interact anymore. We can calculate the exact position of particle A, but because they're entangled, we also know the exact position of particle B. But now what if we measure the exact momentum of particle B? Well, because they're entangled, we also know the exact position and momentum of particle A, a violation of the uncertainty principle. Bond's variant is kind of similar to the EPR paradox and is like the following. So suppose we have a source that emits an electron-positron pair, and let's suppose that the electron is going to be detected by an observer A, and the positron is going to be detected by observer B. And because of superposition, you have to measure their spin or you don't know it. Now, let's suppose that A measures the spin along the z-axis and obtains a plus z or minus z. Because the positron and electron are entangled, B can only measure the other kind of spin. So somehow, these two particles know that the other spin is measured and kind of like change their own spin to fit it. And it seems like information has traveled faster than light, which does not seem possible. And yeah,